Geometry students. Some of y'all have expressed a need or a concern about trying to pass for the third 6 weeks, so I'm going to offer you the opportunity to do a project for the third 6 weeks. It will count as an additional test grade. It's not extra credit, it's just an additional test grade. And how that will help is by putting an extra test grade into the major category. It will actually cause the other tests that are already in there to count as a smaller percentage of your third 6 weeks grade. So if you have some grades in there, some test grades in there that are not doing so good, we probably should have done some retries on those tests. But this would be a way to reduce the overall percentage that those tests end up counting, and of course offer you an opportunity to turn in a project, hopefully get a good grade on it, and that would help in the major category as well. Now let me be clear on one thing. Some of you seem to be under the impression that this is an elementary school class or something, and you think that if you turn in a project, any project, regardless of the quality or the accuracy of it, that you seem to think you're going to be getting a grade like a B just basically for participating or something like that, and that is absolutely not the case. If you were going to turn in a project in high school, you should at least do the project the way it is instructed to be done, and that way you can get those A's and B's that you were thinking that you were going to get just for turning anything in. Let's get it done right. Then you can get those grades that you want. Anyway, the transformations project, as obviously we just came out of the transformations unit, so let me explain to you what I'm going to have you do on this one if you choose to do the project. Okay, so basically the way this is going to work is you're going to need a piece of graph paper, or they actually sell graph poster board out there somewhere if you're interested in going about it that way. But you will need graph paper, you'll need a pencil, you'll need a straight edge. I'm going to add that in right there. And you will need some colors of some kind. Okay, so here's basically the kind of the layout of it. As you move through the steps outlined below, the following guidelines should be followed. All of the quadrants should either be on the same piece of graph paper or graphing board, or if multiple pieces of paper or board are going to be used, they should be of this as the same scale as each other and then attached to each other correctly. Meaning if you start your project thinking it's going to be a little bit smaller than it ends up turning out to be, you can tape multiple pages or multiple boards together in order to accommodate the size of your project. You don't have to completely start over just because your project is trying to run towards the edge of your paper or your board. Each transformation that you do as you move through the project should be drawn and colored carefully in separate colors. Okay, that doesn't mean just trace over your pencil lines in different colors. It means we're actually gonna fill it in. Okay, so we're gonna get a little bit artsy. Okay, make our projects look good after we get the geometry part of it done accurately. All vertices from your initial figure should be labeled using capital letters, and then each new transformation should have appropriate labels, including prime markers, as the new images appear in the other quadrants, and we'll look at that more here in just a second. Okay, so that's the basics of it. Let's take a look at the steps that will be involved. Okay, step one, you are going to construct a drawing of your first and last initials. Okay, and we're going to do that in block form. Okay, so basically you're talking all straight edges inside of your graph. And if you find that here in a minute you don't have enough corner points just using your first and your last initial, you can also include your middle initial in order to meet the requirements of the project. And you can include your middle initial in there if you just want to. That's fine with me. Okay, now you're going to construct these initials in quadrant 1. You can place them in quadrant 1 anywhere that you want. Okay, they do need to be of some substantial size. I would say probably no smaller than 8, 10, 12 units on your graph paper, because one of the transformations you're going to be doing is going to be a dilation where you're going to be shrinking your figure down. So if you start off with some teeny tiny little initials there, by the time you get to the dilation, your figure may become very difficult to work with. So make it a good size. The figure of your initials should have a minimum of 15 vertices, 15 corner points when you're doing your initials. So if your first and last initials, when you do them in block form, if they cannot provide you with at least 15 vertices, well, go ahead and add that middle initial in there so you can get the extra vertices to meet the step 1 requirement there. Label all of your coordinates on your initials in quadrant 1 with a capital letter and with the ordered pairs that indicate where that corner point is positioned in the graph. Okay, so here's where the transformations start to come in. Step 2, from your initial drawing in quadrant 1, we're going to do a reflection across the y-axis into quadrant 2. There, in quadrant 2, you're going to label all of your coordinates appropriately, remembering that this is now an image, okay, not your pre-image, and you're going to include your ordered pairs. Okay, now what that means is when your original figure had corner points like A and B and C and so on, once you do a transformation, remember they're no longer A and B and C and so on. They need a prime marker to indicate that they are a representation of the original, but no longer the original. Okay, so let's look at step 3 there. From your reflection in quadrant 2. So you went from quadrant 1 and reflected into quadrant 2. Now using this image that is sitting in quadrant 2, you're going to rotate that image 90 degrees around the origin counterclockwise, and that will take your figure into quadrant 3. There you will label all of your coordinates appropriately, remembering that this is now an image of an image, so it'll need double prime markers instead of just one prime marker. Okay, so, and you will also include the ordered pairs indicating where all your points are positioned in the graph. Step 4, okay, you just rotated into quadrant 3 using that image that showed up in quadrant 3. You will now dilate that one using a scale factor of 2 to 1, meaning that it is getting smaller. Okay, so your scale factor is going from a big number to a smaller number, 2 to 1. And it is going to be basically a half size image, 2 to 1. It got half as big as it was to begin with in the scale factor. Okay, so our figure is going to shrink down to half of its current size. Okay, so we're going to shrink down, dilate down using a scale factor of 2 to 1, and at the same time we will translate this new image that is trying to show up in step 4. We will move it into quadrant 4, and we will position it so that the coordinate from your image that is the closest to the origin will be positioned at 2, -2. Okay, so whatever corner point you have there that would be the closest to the origin, once you translate into quadrant 4, that guy's going to be at 2, -2, and then all of the sides will adjust their size and move from that point to -2. As always, you will label all of your points, label all your coordinates appropriately, remembering that it is now an image of an image of an image, so you're going to need 3 prime markers, and of course you're going to also include the ordered pairs. After you get all your transformations done, you're going to color it, you decorate it, okay, elaborate on it, okay, do whatever you can, get all artsy and creative with it, okay, so that it makes a pretty project, not just an accurate project. Okay, so the scoring, each step including the accuracy and all instructions being followed correctly, that will be 4/5 of the grade. Okay, and the final 1/5 of the grade coming from creativity, originality, neatness, and professionalism. Okay, so I'm going to walk you through an example of how this might look once you get finished with it. Okay, and then we'll take a look at the scoring rubric so we can make sure we're totally on the same page about how the final project is going to be graded. Okay, so taking a look here. Okay, there is quadrant 1 where I currently have my initials MH sitting in quadrant 1, and you can see they are in block form. I haven't used any crazy curved lines or anything, so my initials are positioned in the graph paper neatly. Everything meets up with a corner of the grid in the graph paper, so it's very easy to work with. Okay, so I have far more than 15 vertices on my two initials there, so I do not need to include my middle initial. I could include it if I wanted to, but since I had my 15, didn't see any reason to, unless maybe you just want to do that extra work, possibly get some extra credit. We'll see how it goes. Okay, so step one was to construct your initials in there and to label your points. Okay, and also include the ordered pairs that go along with those positions. So I started off on the H there, and I started labeling them: point A, point B, point C, D, E, F, G, and so on. Now clearly I did not label the entire figure. Okay, just wanted to give you enough to get the point. Okay, but on your project you will go around and you will label all of your corner points going through the alphabet and provide where those ordered pairs are positioned within the graph. Step 2 was to reflect the figure across the y-axis. Okay, now remember from your discussions on transformations, to reflect across the y-axis, it is the x value that is going to change its sign. The y value remains the same. So there is basically my initials reflected through the y-axis. And once again, I will label my points, remembering that this is not the original figure anymore. This is now an image. So A and B and C and D and so on become A prime and B prime and C prime and D prime and so on. And I'll do that for all of the corner points, even though obviously in the graphic you're looking at there I did not complete it. Step 3 is to rotate your figure around the origin. Okay. Now if you will recall, okay, oh, got some problems right there. Let me fix this real quick. In order to rotate your figure, the abscissa and the ordinate, which is to say the x values and the y values, they are going to switch positions, which I forgot to do there. Okay, but got it now. Okay, they will switch positions, and then you have to watch out for your signs. In quadrant 3, everything is going to be negative. But anytime you rotate around the origin, your abscissa and your origin, or abscissa and your ordinate are going to switch positions if you're only rotating 90 degrees, and then depending on which quadrant you're in, you pay attention for possible sign changes. Okay, so I would do that for all of my coordinates. Step 4 is to dilate your figure by a scale of 2 to 1 and translate into quadrant 4 such that the point that's closest to the origin would be positioned at 2, negative 2. Okay, so there is the dilation of 2 to 1. Okay, since our scale factor went from a big number, 2, to a smaller number, 1, okay, that indicates that it is a reduction, so my figure got smaller. Okay, 2 to 1 indicates that if the figure that you started off with was 2 units tall, then your figure that you end up with would be only 1 unit tall. So I got half as big on the translation, or on the dilation. Now that means you're going to have to probably count out your squares and see how long particular sides are. Maybe even use a little slope, a little rise over run to figure out where some of these diagonal lines are getting to, and then apply the same idea. Take half of that slope, take half of those links in order to figure out how big your sides of your figure should actually be. Once again, you will label all of your vertices, okay, remembering now that this is an image of an image of an image, so we've got triple primes on all of our vertices. And since we had to do a reduction, went from a scale factor of 2 to 1, it's possible you might end up with some fractional values, some fractional positions in your graph. So pay close attention to that. Not everything always ends up at whole numbers inside of graphs, guys. So pay attention to how long and where those points would be positioned. If you don't get them correct, that would be a reason why you would lose points, just like anything else on there. Okay, so that would complete the first 4 steps. And then the 5th and final step, as I said, would be to color everything different colors for the different transformations that are there. Of course, you can get creative. I expect you to do a better job than I did there. I scribbled that in a big hurry on my smartboard, and the board is not calibrated correctly, so I'm outside of the lines in a few places. I would expect you to do a better job. Okay, so you're going to be using straight edges and pencils in case you have to erase Okay, and then you can maybe use a marker or something like that to straight edge in the boundaries of your figures for your 4 different quadrants there, color them in, do a good job. Should be a bunch of easy points that you can get on there. Anyway, that is the project if you feel like doing it in order to get that additional test grade. And here is the rubric real quick. As you can see, on each of these, original drawing, reflection, rotation, dilation, and so on. Each of the different transformations has several things I'm going to be looking at. The figure itself, did you get it correct? The coordinates, did they get labeled and identified correctly? The coloring, did you do a neat and good job with the coloring requirements? Same thing with the reflection and the rotation and the dilation, all scored basically the same way. And then you have those easy 20 points, should be an easy 20 points, for being, creative, original, neat, professional, all that kind of stuff. And again, as we always say on those projects, a lot of people think, appearance shouldn't matter and things like that. We ought to be able to dress the way we want, look the way we want, do what we want. People shouldn't judge us for things like that. And I'm sorry, the world just does not work that way. You will forever be judged upon the overall appearance and quality of the work that has your name on it, as well as the appearance that you project, okay, of yourself. Okay, so anyway, as always, that bit of information is always included in your grade because it's always something that counts for you or against you in life as well. Anyway, if you choose to do the project, that's how it needs to be done. The project is going to be due, I put at the beginning of the page here, December 12th. Okay, that is 1 week from this Friday if you choose to get the project done. Completely up to you, but there is the project if you choose to do it.